Okay, Wes, file snapshots. What in the world are those things?
All right, file snapshots. It's one of our point-in-time copy tools, and it's a function of Veritas file system.
Oh, okay.
We're just taking a snapshot of an individual file, and we can have unlimited number of snapshots from a base file. And there's no differentiating between which one is the original snapshot, which one or which one's the original and which one's a snapshot. They are equal.
Well, why can't I just do a copy? Isn't that the same thing?
Not exactly, because once you make a copy of the file, everything is different. There's no cost savings in performance or disk space.
Oh, okay.
So that's what we're looking at here.
Okay.
Savings in performance, savings in disk space. So there's a lot of stuff happening behind the scenes when you create a file. So create a file on my system, I'll just call it file 1. When I create this, we need to allocate an inode to this, we need to allocate disk space to this from our free block maps, and we need to identify the locations where the data is going to reside and write the data to disk. So when we do this, we're going to allocate contiguous disk blocks known as extents. And in the inode, we're going to have direct pointers that point to an address length pair, which is basically saying that at this starting address is where my file is located on disk, and it goes for this length of blocks. So when I write my data down here, it's going to go out here, and I get the starting address and a length in blocks for that file. And I may get a single extent, or I may get multiple extents, depending on the amount of contiguous disk blocks that are available and the size of my file. So typically, this will be the exclusive owner of the extents associated to that file. Well, when I create a snapshot, and this is the case where if I made a copy of my file, I'm going to get a whole new set of blocks allocated to this. Okay? But when I do a file snapshot, what we're going to get is essentially a copy of my original file. So this would be my snap, okay, of my original file. But we are now going to have this pointing to the same extent. We call them shared extents. So as long as the data in that extent does not change between these files, we have shared extents. And we get some good performance benefits from this. When I load shared extent information into memory in my memory page cache, I only have to do it once. So if I'm looking at this file or looking at this file, or I create 100 snapshots of the same file, as long as they all see the same data in that shared extent, I only need one copy of it in memory. Okay? So savings of space in memory and enhancement in performance, since we're sharing it all. But one of the things that sets this apart from like hard links and logical links and stuff is that I can also write independently to these individual files. I can have unique data. So as long as the data is the same, then both of them share an extent. But if I then do a write to one of these files, we're going to do a copy on write action. The original blocks that are going to be affected will be written out to new space. We're going to allocate new blocks for it. Then this file is going to be exclusive owner of those blocks.
But you're not copying the rest of the file.
No, just the
that
data
area.
is changing.
Okay.
Okay. So for anything that hasn't changed, we still use the shared extent. For anything that has changed, we're going to track it uniquely by an individual file. Okay. So I can change data here, and it has its own blocks that it tracks, and this one has its own blocks that it tracks. And then for the common stuff, we use the shared extents. Okay. Now, this is wonderful for virtual machine environments, whether it's VMware, KVM, Hyper-V, it doesn't matter. We can take a snapshot of a virtual machine, because let's face it, in a virtual machine, we have an operating environment where the majority of the files that are in there are static. They're not going to be changing over time. So we can create snapshots of a virtual machine, and all the files that are static, shared extents. All the files that make it unique are self-owned.
Fantastic. So what I see here is the capability or the possibility of being able to not share, but well, you share data, but also save storage.
Oh, big time.
If we use or customers use file snapshots in an optimal way.
Exactly. Performance and saving space.
Fantastic. Thanks for sharing that with us, Wes.